All right. So we have a related rate problem here. A triangle has a base and height that are equal, period. If dH dt equals 3 inches per minute, how fast is the area changing when the base is 10 inches? Now, I could have written this another way if I wasn't in a hurry. I could have said if the height is increasing at a rate of 3 inches per minute, right? But I took out all the English and just wrote math. I guarantee that on test, huh? Yep. So it says, first of all, do we agree that the base and the height are equal? Let's start with that fact. And then I told you dH dt is a constant rate of growth of 3 inches per minute. How fast is the area changing? dA dt is equal to question mark, right? When the base is 10 inches. All right, I won't give you the area. I won't give you the area of a triangle or a circle or a rectangle. If you don't know it, I guess it's tough times. All right, area of a triangle is 1/2 base times height. I see that I've been given dH dt and the base of 10. All right, so the first thing I do is I say, hey, I know dH dt, I know b equals h. If I take the derivative of this right now, I'd have to do the product rule. So I don't want to do that. So I would, personally, I would substitute in, for the base, I would substitute in the height. I think that becomes 1/2 hh, which is 1/2 h squared. Now I look at this and say, oh, I can take the derivative of this function. All right? And if I do that, I get dA dt, right? Because the derivative of a is 1. Derivative of 1/2 h squared, I believe, is 2 times half is 1. So how about h dH dt? I want to find dA dt. I have dH dt. I don't know h directly, but b equals h, and I told you the base was 10. So maybe right here I would even be lazy and say, hey, I can write h is 10 too, right? So now I know h. Now it is simply plug in, chug, dA dt equals 10 inches times 3 inches per minute. I think the area at that instant is increasing at a rate of 30 inches squared per minute. Pretty straightforward. All right, pretty straightforward related rate problem. I want to do this another way. Do you agree no matter what happens now, we've determined that dA dt is 30? All right. I want to be clear that if I come back up all the way here and I group all this, that we can do this another way. And I can say, I don't want to do this. I want to take the derivative of dA dt right now and not so. I don't know why you would do it this way, but it's important for us to see that the chain rule, or the product rule will work here. So guys, derivative of a is still dA dt, right? Now the problem is, what's the derivative, if I do it with respect to b, what's the derivative of b? 1, right? So we get 1/2 h dB dt, right? Plus, what's the derivative of h? 1, so we get 1/2 b dH dt. Now the problem with this immediately, and maybe you can catch it and maybe you don't, is, well, we know base and height, right? We agreed that those were 10, right? We know dH dt, right? But what don't we know right now? We don't know dB dt. You guys agree? But I have this beautiful equation up here. What's b equal? H. What if I take the derivative of both sides of b equals h? dB dt equals dH dt. All right. So now I know that this would also equal dB dt. You guys agree? So now I can fill this in. dA dt equals 1/2 times 10 times 3 inches per minute, right? Plus 1/2 times 10 times 3 inches per minute. What's a half plus a half? Last time I checked, half plus a half is a whole. So the half of 10 times 3 plus a half of 10 times 3 is 1 times 10 times 3. Oh, look! It's still 30 inches squared per minute. Yes, no matter, this is a much worse way. I would definitely do it the first way, but it works either way. All right?